In today's lesson, we are going to be looking at sine and cosine law applications. So similar to our application lesson from or for right angle triangles or right angle trig, this is just going to be focused on applying the sine and cosine law, but to word problems instead of just general triangles. So in some cases, we may have to figure out the triangle on our own. In some cases, it may be drawn for us and we have to understand what it's asking for. So in the first question, a cable car stops part of the way across an 86-meter gorge. The cable holding the car makes an angle of depression of 57 degrees at one end and an angle of depression of 40 degrees at the other end. How long is the cable that holds the car? So we already have this triangle drawn for us, but again, just to remember, angle of depression is from a horizontal line down. So we have our two angles of depression here. We know it's 86 meters across from one point of the gorge to the other, and we want to figure out what is the length of the cable holding the car. So that means we're looking for this side, side B, and for this side, side A, and we're going to add those two sides up to figure out the entire length. So we can clearly see it's not a right angle triangle. There is no implied right angle. There is no right angle kind of given to us in the triangle. So that means we have to use sine or cosine law. So now we have to figure out which one is which, or what law to use. So if I look at this, right, we have to look for what are the key pieces of information we need for either law. Now, you could go through and start by saying, okay, I'm going to go through and circle all my pairs. But I would start with looking for cosine law, because really there's only the two scenarios. Right? So for cosine law, if we're trying to find side lengths, we need a sandwiched angle, which in this case we don't. We don't have a side angle side, side angle side. We don't have that. We're missing a side to find the other one. I also can't find an angle because I don't have all three sides. So I can't use cosine law. Let's see if we can use sine law. So if I make now my pairs, I see that I have all half pairs. Right? I don't have a full pair anywhere. But I could make a full pair because I can find out this angle here by doing 180 minus 57 minus 40 to get that third angle, which I get is 83 degrees. So now I know this angle here, and now I have a full pair and two half pairs. So now I can find my missing side lengths for using the sine law. So it doesn't matter which one we start with, but remember, we make sure when we're using our formula, we put the side length on top. So sine B, little b over sine B equals, we have to use C because that is the one side that one full pair we do have, over sine C. So side B we don't know. Sine B, or sine of 40, is equal to 86 over sine 83. B is equal to, and again, we said when we were trying to solve this, we bring the sine 40 up. So we have 86 times sine 40 divided by sine 83. Now this just becomes one calculation. So 86 times sine 40, then divided by sine 83, we should get 55.7, or we can round it to 56. So the length of the one part is 56 meters. For the other side, I'm going to do the sine law again. Technically, if we go through and say, okay, well, now I know this is 56. To find A, I could use cosine law because I do have the sandwich angle of side, angle, side to find that other angle. Or I could use the sine law to find that missing side because now I have, again, full pairs and half pair. So whichever law you choose to use is up to you. I'll use sine law just to keep it consistent. That's what some of you have said you prefer. So now if I'm looking for side A, side A over sine A, side C over sine C. I technically could use the B pair because I do know angle B and I do know side B, but I would stick to using C because we're pretty confident we know that those are what our values are. There shouldn't really be much of a mistake in finding that missing angle, and that side is already given to us. So we're pretty confident with knowing what those measurements are. There could have been an error when we calculated this side length of 56. So I'm going to stick to using which sides I'm pretty confident or that I know that they're correct. So set up my formula. Let's plug in our information. We don't know side A. We do know sine of 57 because that is angle A. C again is 86 over sine 83. So very similar setup to the last one. We're going to bring the sine 57 up and multiply. So 86 times sine 57 divided by sine 83. Again, same calculations. Multiply your two numbers on top or multiply everything on top. 86 times sine 57 divided by sine 83. We get 72.7, or again, rounding to the nearest meter, 73. So now I know the two pieces. I know the two parts, or the two side lengths of my triangle. And the question is still looking for, we're not done yet, is how long is the cable? So I need to figure out the entire length of the cable. So I need to figure out this length and add them together. I do have those two values already. So we can say that the length is equal to, you can say A plus B if you want to be technical. And we could say then 73 plus 56. And we should have 129 meters. So the length of the cable that's holding this car is 129 meters. Looking at another example, a sewer pipe for a new subdivision has to be laid underground. A connection is made to the main service pipe at either end of a 4.9 kilometer stretch of road. One pipe is 2.5 kilometers long and it makes an angle of 72 degrees at one end of the road. So we don't have a drawing now, so we need to draw this out. So we have our main pipe. We have our main pipe. So we have our main pipe that is 4.8 kilometers long because it is along the 4.8 kilometer stretch of road. One pipe is 2.5 kilometers long, and it makes an angle of 72 degrees at the one end of the road. And we can assume that there is another pipe that connects the two. We don't know what the angle is, and we don't know what this angle is. And we don't know what this side is. So those are all pieces of information that we don't know. But based off of what the question gives us, we can label it as such. Now question A is saying calculate the length of the second pipe that will connect to the first pipe to the other end of the road. So I want to calculate this measurement. So if I want to calculate that, again, looking at our triangle, there's nothing to indicate that we have a right angle triangle here. So I need to figure out, okay, what law do I use? The sine law or the cosine law? Well, looking at this, again, I would start with the cosine law, check for the either all three sides or the side angle side sandwich. In this case here, we do have a side angle side. So I do have a side angle side or a sandwiched angle, so I can use cosine law. If you weren't sure, again, double check. You could use, you could pair up your sides and check to see, do you have a full pair and a half pair? You would find that you have neither. You only have half pairs, so you'd have to use cosine law. I can't even find any of these other angles to try to use the sine law similar to what we did in the last question. So this has to be cosine law. I am going to just label our sides A, B, C, just to help us use the formulas. It doesn't really matter which how you label it. That's however you label is up to you. Just make sure you can then use the formula properly. So I'm looking for side B. So I'm looking for side B across from angle B. So my formula is going to be B squared equals A squared plus C squared minus 2AC times cosine B. Again, this is just straight from our cosine law note. I'm going to plug in my information. I don't know the angle or the side. I do know A and B. A is going to be 4.8 squared plus C, which is 2.5 squared, minus 2 times 4.8 times 2.5 times cosine B, which is 72. B squared equals, again, as we talked in the lesson, we can do this entire calculation all at once as long as we're comfortable with our calculators. 2 times 4.8 times 5 times cosine 72, and we should get 21.87. If you look at that answer, you'd probably say that looks a little bit too big, and you'd be right because we do have one more step of square rooting that answer. So we square root that answer, and we get 4.68. So 4.68 is the length of that second road. When you put that measurement in now, we do know this length is to be 4.68. And now the second question, part B, asks, what is the measure of the angle made by connecting the two pipes? So we're going to be looking at, I guess it doesn't really specify which pipe. So for our purposes, let's just say it's these two pipes, the two that are not that aren't connected, or that we're not talking about the main road, we're talking about the two pipes for the subdivision. So if I'm looking for angle A, so I don't need to do that yet. If I'm looking for angle A, I need to figure out, okay, what information can I use to find that angle? Well, here again, it depends on what you'd rather use. We do have a full pair for side B, or for B. We have the side B and angle B, and we do have half a pair of the side but no angle. We also have all three sides. So whichever method you prefer, sine law or cosine law, is up to you. I'm going to keep it consistent with A and use cosine law just so we have the practice with it. So I'm going to be looking for cosine of angle A. That means my formula is going to be B squared plus C squared minus A squared divided by 2BC. Again, this just comes from our note. Cosine A is going to equal B squared, which is 4.68 squared, plus C squared, or 2.5 squared, minus 4.8 squared for side A, and then 2 times 4.68 times 2.5. Again, here, as we mentioned in the cosine law lesson, might be easier to calculate the top first, calculate the bottom separately, and then divide your numbers. So we get 5.11 divided by 2 times 4.68 times 2.5 divided by 23.4. Okay, cosine of our angle is equal to 0. 0.218. Again, you might look at that and say that looks a little bit too small, right? And you'd be right. We do have to do the inverse anytime we're trying to find an angle. So now we do A is equal to cosine -1 of 0.218. And we get an angle of 77 degrees. So in this question, we've now determined that this missing angle between the two pipes is 77 degrees. If we wanted to, we could figure out at what angle does the pipe join the end of the main one or at the end of the road by just doing 180 minus the two other angles. Although the question doesn't ask, or there isn't a question that asks us for that, so we don't need to. Again, this is just kind of an idea, just application questions for using sine or cosine law. The main thing is just being able to visualize the triangle and then determine what type of law to use. Again, we know these ones are going to be sine or cosine law because they don't have a right angle in them. Again, make sure you are comfortable using the sine and cosine law to determine missing sides or angles.